So imagine you're hiring a really brilliant, highly capable freelancer, right?
Okay.
Now imagine hiring 50 of them,
Oh boy.
and you lock them all in this massive conference room together, give them absolutely zero management, and just tell them to figure out how to run your company.
That is well, that's a recipe for total corporate collapse.
Exactly. It sounds insane. But surprisingly, that is exactly what the tech world is doing with artificial intelligence right now. Welcome to today's deep dive. We are looking at a fascinating paper by Dr. Jonathan H. Westover, and it's called Managing the Machines: Organizational Design for Multi-Agent AI.
Yeah, it's a great piece.
And the core premise here is just this massive paradigm shift because, we're moving past the era of just using single AI assistants, and we're rapidly building these really complex multi-agent systems, like entire teams of bots working together.
Great networks of them.
Yeah. But the secret to keeping these artificial teams from completely tearing themselves apart, it isn't actually found in some new programming language.
No, it's not. It's not found in computer science at all, really.
Right.
I mean, the solution we are exploring today is coming directly from century-old human management theory.
Which is wild.
It is. We are basically discovering that the only way to effectively govern this incredibly cutting-edge technology is to look at it through a deeply sociological lens.
Okay, let's unpack this, because before we get into, why bots need middle management, we really have to establish the baseline of where AI capability is right now.
Right.
There's this concept from a 2023 researcher named Del Acqua. He calls it the jagged frontier of AI.
Yes. The jagged frontier.
So what does that actually mean for the listener who is just using these tools every day?
Well, so if you visualize human capability, it generally follows a somewhat smooth, predictable curve, right? Like, if you are highly proficient at calculus, you're probably going to be totally fine at basic algebra.
Right, that tracks.
But AI capability does not work that way at all.
Yeah.
It is incredibly jagged. I mean, an AI might operate at a literal genius level when it's analyzing some super complex legal contract.
Yeah.
But then it might fail spectacularly at basic spatial reasoning or, simply counting the number of letters in a word.
Oh, yeah, I've definitely seen it do that.
Exactly. It's wildly uneven.
And if you're just using a single AI tool to, say, help write emails or summarize reports, you naturally adapt to that jaggedness. You sort of learn its quirks.
You do. You figure out what you can trust it to do, and you know what it's terrible at.
Right. But Westover points out that enterprises, they're no longer stopping at one AI.
No, they're linking multiple AIs together into these multi-agent systems.
And the adoption rate is staggering, isn't it?
Oh, absolutely. There was a 2023 Gartner survey cited in the paper, and it showed that 18% of enterprises were already exploring these multi-agent architectures.
Wow. Almost 1 in 5.
Yeah, and the reasoning is largely driven by task complexity and, well, cost optimization.
Right, because you want to save the expensive models.
Exactly.
Yeah.
You can route simple, repetitive data entry tasks to a very cheap fast language model, and then you save your massive, expensive frontier models for the heavy analytical lifting.
Okay, so how are these bot teams actually structured? I mean, they aren't just thrown into a digital pile, right?
No. They generally take a few specific architectural forms. So you have sequential pipelines where work basically moves down a line.
Like an assembly line.
Right. Agent A extracts data, passes it to Agent B to analyze, who passes it to Agent C to write a summary.
Makes sense.
Then you have parallel confederations. That's where multiple agents research different angles of a topic simultaneously, and then a synthesis agent brings it all together at the end.
Okay.
And finally, you have hierarchical orchestrations, where a supervisor AI directly commands a bunch of subordinate AIs.
So, I mean, that makes total sense on paper. You break the work down. But compounding that jagged frontier we talked about across dozens of interacting bots, that just sounds like a powder keg.
Well, if we connect this to the bigger picture, the traditional vocabulary of software engineering completely fails us here.
Really? How so?
We use terms like APIs, control planes, orchestration loops.
Yeah.
But those terms describe deterministic machines. When you network these highly unpredictable, jagged agents together, they don't interact logically. The interactions become emergent and, frankly, chaotic.
So instead of a seamless digital assembly line, you get the digital equivalent of a highly toxic, dysfunctional office environment.
Basically, yes.
Because the real-world pathologies Westover details in this paper, they are mind-blowing. Let's talk about the emergent behavior risk.
Oh, the Microsoft Azure example.
Yeah. Microsoft Azure DevOps deployed multiple agents under a high workload, and 2 agents ended up locked in what the paper calls an unintended reciprocal feedback loop.
Yes.
How does that practically happen? I mean, don't they only speak when they're spoken to?
Normally, yes.
Oh.
But these agents were designed for completely different purposes.
Yeah.
So Agent A outputted a piece of data. Agent B, based on its own specific instructions, misinterpreted that data output as a brand new task request.
Oh, no.
So Agent B processed the data and sent a confirmation back. But then Agent A read that confirmation as a new task.
Are you serious?
Yeah, they locked into an infinite loop of passing work back and forth. They ended up eating up 34% of the entire system's compute resources before human engineers finally noticed and pulled the plug.
Wait, hold on. You're telling me two bots endlessly arguing in a loop is an organizational failure?
Yes.
Because that sounds like a lazy programmer just forgot to write a stop command. Like, can't you just hard code a limit on how many times they're allowed to reply to each other?
It is so tempting to view these issues as simple bugs. But putting a hard limit on replies is just a Band-Aid. It's not a cure.
Okay.
The root cause wasn't a missing line of code. It was a fundamental lack of clear role definition. Neither agent actually knew what its boundaries were.
Oh, I see.
And the pathologies get much more insidious than just infinite loops. Like, consider the knowledge fragmentation problem.
Right.
Dr. Westover details this insurance company that used 5 specialized agents in sequential pipeline for claims processing.
So one bot hands the claim to the next, right down the line.
Correct. And it ran beautifully for 8 months.
Wow, 8 months is a long time in tech.
It is. But what the human operators didn't know was that a retrieval agent at the start of the pipeline, the one pulling the initial policy data, had slowly drifted.
Drifted how?
It started making subtle, consistent errors in how it formatted the data before passing it along.
But wait, nobody noticed for 8 months? If the data was formatted wrong, shouldn't the whole system have just crashed immediately?
Well, it should have.
Mm.
But it didn't, because a downstream agent, the one receiving the flawed data, it's secretly adapted.
What?
Yeah. The underlying machine learning model noticed the formatting change and organically learned to compensate for the flaws so it could keep outputting the correct final result.
That is wild. I mean, it's exactly like a worker silently redoing a colleague's sloppy spreadsheets every single week rather than just reporting the issue to the boss.
It's exactly like that.
The final report looks fine, so management thinks everything is perfect.
Right. But it created a deeply hidden, implicit dependency. Neither agent was actually functioning to its original specifications anymore. But together, they masked the failure.
Okay, so how did they find out?
Well, engineers pushed a routine update to the retrieval model to fix the formatting drift.
Oh, boy.
And by fixing the first bot, they broke that secret reliance. The downstream agent had completely forgotten how to read the correct format, and that caused a massive 3-day system outage.
So the technical fix actually broke the system because the underlying organization of the bots was completely opaque.
That is the core of the issue, exactly. Or take the diffusion of accountability.
Yeah, let's get into that.
There was a healthcare AI vendor that audited their diagnostic system. They discovered that 64% of their errors involved multiple agents interacting.
Okay.
But the system was designed so that only the final agent in the chain ever received an error flag.
Ah, right. The classic many hands problem. If 5 different departments touch a project and the project fails, everyone just points fingers at the last person holding the bag.
Exactly. It is siloed information and accountability diffused just on a digital scale. I mean, an API hook only tells an agent the technical parameters of how to send a data packet. It does not tell the agent who actually holds the authority to make a final medical diagnosis.
Here's where it gets really interesting, I think. Since we can't just write a Python script to fix, toxic office politics among bots, Westover argues we have to force the AI to follow the literal rules of human corporate management.
Yes.
And the very first step of that is establishing decision rights.
Decision rights are fundamental to any functioning organization.
Yeah.
In a human company, there is a clear, understood line of authority, right?
Right.
Like a cashier can process a refund up to $50.
Right.
But they mathematically cannot process a $51 refund without a manager coming over and overriding the system.
Yeah, they need a key or a code.
AI needs those exact same authority boundaries explicitly encoded.
And the paper highlights Salesforce's Einstein GPT as a prime example of getting this right. They use a tiered system for customer service.
They do.
The Tier 1 AI agents, they are empowered to handle basic inquiries completely autonomously. but they are given a very strict mathematical confidence threshold.
Right, the 0.7.
Exactly. If the agent's internal confidence score for generating an answer drops below zero point 0.7, its decision rights are instantly revoked.
It is forced to escalate. The task automatically routes to a more advanced Tier 2 reasoning agent or just gets kicked up to a human operator.
Right.
And by establishing this explicit digital chain of command, Salesforce achieved an 89% first contact resolution rate, and they did it without sacrificing the safety or the accuracy of the answers.
Okay, so that establishes a digital chain of command. We know who is allowed to make a decision.
Right.
But how do we solve the problem of them completely misunderstanding each other, like those Azure bots getting into an infinite loop?
Well, we use a concept from sociology called boundary objects. And I have to say, the way this applies to multi-agent AI is absolutely brilliant. It is perhaps one of those elegant solutions in modern software engineering.
I love how excited you are about this. Break it down for me. What exactly is a boundary object?
So think about large human organizations. The engineering department speaks in highly technical specifications, right?
Yeah.
But the marketing team speaks in broad customer narratives. So if marketing just yells a vague idea across the hallway, engineering will completely misinterpret it.
Every time.
Right.
Yeah.
So how do they coordinate? They use a boundary object,
Okay.
a standardized IT request form, a JIRA ticket, a formal creative brief. It is a shared, rigid structure that forces different groups to translate their specific knowledge into a universal format that absolutely everyone understands.
Right. It's like having an issue with your laptop and having to fill out the IT ticket. You can't just type, "My computer's acting weird." The form forces you to pick a hardware category, list your operating system version, copy the exact error code. It forces you to be clear.
It removes ambiguity. And now, apply that to large language models. Because these models are so incredibly good at generating text, developers are highly tempted to just let the agents chat with each other in conversational English.
Which sounds easier.
It does, but English is inherently ambiguous. It leads to hallucinations, misunderstandings, and, well, infinite loops. Multi-agent AI needs its own IT tickets.
Which is exactly what Bloomberg GPT implemented for their financial analysis bots. They do not let their agents casually chat.
No, they don't.
They force them to use strict data contracts, specifically JSON formats. But it's not just about using JSON. It's about what the contract forces the AI to include.
Right. The architecture of the payload is what matters. Bloomberg mandates that every single time an agent passes data to another agent, the JSON object must contain specific fields.
Okay.
It must list its verifiable data sources, and crucially, it must include an explicit numerical confidence score.
So they're mathematically forced to show their work.
Yes, forcing an AI to explicitly state its confidence score in a standardized format before handing off work. It's the precise equivalent of a human coworker sliding a physical report across your desk and saying, "Hey, I'm not totally sure about the Q3 projections on page 4, but here is the data I pulled."
Right.
It provides essential metadata about uncertainty.
Which immediately gives the receiving agent the context it needs. It looks at the JSON, sees a low confidence score, and knows to either treat the data with skepticism or flag it for human review.
It creates absolute transparency at the point of interaction. And by forcing their agents to communicate uncertainty explicitly through these boundary objects, Bloomberg reduced the amount of time human analysts had to spend manually validating the AI's outputs by 34%.
That's massive.
It is. The inconsistencies weren't hidden in conversational text anymore. They were flagged right at the boundary.
Okay, so we've established decision rights, and we've given the agents these rigid IT tickets to prevent miscommunication. But if we are building a full corporate structure for AI, someone has to actually be the boss.
Right.
We have to figure out how these bots are grouped.
And this brings us to a foundational management principle from 1937. It was developed by Luther Gulick.
Okay.
He popularized the concept of span of control. Gulick observed that a human manager can only effectively supervise a limited number of direct reports, usually around 5 to 7 people.
Any more than that, and it gets messy.
Exactly. Beyond that number, the manager becomes a bottleneck. They can't keep track of everything, communication breaks down, and quality plummets.
And naturally, software engineers building these multi-agent systems probably thought, well, these are computers. They don't sleep. An orchestrator AI can surely manage 100 subordinate AIs simultaneously.
And they were completely wrong. Dr. Westover points out that AI orchestrators suffer from their own version of cognitive overload. Yeah. In technical terms, it is a combination of context window overload and combinatorial complexity.
Okay, let's make sure the listener understands the mechanics of that. What actually happens under the hood when an orchestrator bot tries to manage too many workers?
Right. So an AI's context window is effectively its working memory. It's how much text and instruction it can hold in its head at any given moment.
Okay.
If an orchestrator bot is trying to read the outputs of 20 different specialized agents, reconcile all their conflicting information, remember its original prompt instructions, and issue new commands.
It's too much.
If working memory gets completely maxed out, it literally starts forgetting earlier instructions.
Mm-hmm.
And then add to that combinatorial complexity, which is the sheer number of possible interactions between those 20 agents, and the math just becomes impossible for the model to navigate.
So it breaks down.
The failure rates increase exponentially, yeah.
Which Shopify found out firsthand. They built this massive customer support AI setup. And originally, it was just a flat structure. They had one single orchestrator bot trying to directly manage 12 different specialized agents all at once.
And the result was absolute chaos. The orchestrator's context window was overwhelmed, started getting confused, sending order tracking data to the returns agent or pulling completely irrelevant information for the customer.
So Shopify had to draw an org chart.
Yes.
They moved from that flat structure to a two-tier architecture. They created 4 supervisor agents, one strictly for orders, one for returns, one for technical issues, and one for account management.
Right.
And each of those supervisors only manages 3 to 4 specialized sub-agents.
It is a textbook application of Gulick's 1937 span of control, and the results are undeniable. Just by reorganizing the reporting structure of the AI without changing the underlying foundational models at all, Shopify cut average handling time by 29%.
Wow.
And they boosted customer satisfaction by 18%.
Okay, but let me play devil's advocate here for a second.
Sure.
Are we genuinely just recreating human bureaucracy for machines? I mean, everybody complains about middle management, red tape, endless layers of approval. Are you saying the ultimate fate of cutting-edge AI is to become a giant bureaucratic machine?
What's fascinating here is that the answer is absolutely yes.
Really?
Yes. We often use bureaucracy as a pejorative term.
Yeah.
But in complex, high-stakes systems, hierarchy, modularity, and explicit reporting lines, they're not just red tape. They are literal safety nets.
I see.
They are the mechanisms that stop a localized error in one specific department from cascading and destroying the entire company.
Because, I mean, a mistake on a T-shirt return is one thing, but Morgan Stanley is using multi-agent assistants for their financial advisors.
Exactly.
That involves massive data retrieval, portfolio analysis, strict compliance checking. The stakes for that firm are existential.
Which is why Morgan Stanley manages this through tiered monitoring, which is another highly bureaucratic concept. Routine, low-stakes data retrieval tasks are logged, but they don't require human approval to proceed.
Okay.
However, if the multi-agent system tries to draft a communication regarding any transaction over $500,000, it hits a hard stop.
Wow.
It triggers a mandatory human review. And by combining AI autonomy with strict bureaucratic checkpoints, they reduce compliance incidents by 90%.
That's incredible.
Kaiser Permanente did something very similar for medical diagnoses, actually. They created a literal physician-led oversight committee just to manage the governance of their AI agents. And they successfully scaled it to 10 million interactions.
Bureaucracy is the ultimate safety net. Incredible. But let's bring this back to reality for the listener, If companies are building these massive self-managing AI org charts, where does that leave you?
Right.
Like, what does your daily job look like when the bots are doing the work and managing themselves?
Well, it represents a fundamental shift in the definition of knowledge work. Historically, your value in a workplace was inextricably tied to your domain expertise, right?
Right, your specific skills.
Your ability to personally execute a specific workflow, whether that was writing code, drafting legal contracts, running financial models. But as multi-agent systems take over the execution layer, the human's role shifts dramatically toward exception handling and system supervision.
So what does this all mean? It means your value is shifting from doing the work to conducting the AI orchestra. You are no longer playing the instrument.
That's the core of the issue. And playing an instrument requires a very different skill set than conducting. The new vital skill is metacognition.
Metacognition.
Right. It's the ability to step back and deeply understand the workflow dynamics. You need to know how the different AI agents coordinate, understand their individual jagged frontiers, and know exactly where their collective blind spots are so you know when to intervene.
And that makes trusting the system incredibly complicated. We talked about how hard it is to know when to trust a single AI.
Oh, yeah. But with multi-agent systems, that jaggedness is squared. You might fully trust the research bot, and you might trust the drafting bot. But how do you know what they're going to produce when they collaborate behind your back?
It is a massive challenge in trust calibration, and that is precisely why the most forward-thinking organizations are realizing this is not just an IT deployment. It is a profound cultural and organizational shift.
Yeah.
Look at Unilever. They created an AI orchestration guild. And they didn't just staff it with software developers. They brought in process owners and organizational effectiveness specialists.
Because you need people who understand how work actually flows through a company, not just people who know how code compile.
Exactly. By treating multi-agent design as a cross-functional sociological discipline, Unilever reduced the time it takes to get a reliable AI system into production by 40%.
And the UK government digital service went a step further. They published a multi-agent design playbook. Its entire purpose is to mandate a shared vocabulary, ensuring that policymakers and software engineers are speaking the exact same language when designing these automated workflows.
And Spotify built their entire approach around a culture of deliberate A/B testing. But they don't just test different algorithms. They constantly tweak the org chart of the bots themselves, changing reporting lines to see which structure performs best.
The overarching lesson here is that organizations must stop treating multi-agent AI as a purely technical experiment. Governing these systems requires the expertise of organizational psychologists just as much as it requires machine learning engineers.
What a massive shift in perspective. We started this journey by looking at the jagged frontier of individual AI tools.
We did.
We explored how locking them together into multi-agent systems can create toxic digital workplaces, right? Bots caught in infinite loops or secretly covering for each other's formatting mistakes until a whole system crashes. And we learned that the cure for these technological pathologies isn't writing more code. It's applying century-old human management principles. Spans of control, boundary objects, decision rights.
To effectively govern artificial intelligence, we basically have to force it to adopt human corporate structures.
So as you see these complex multi-agent tools rolling out in your own industry, remember, understanding how the AI is organized behind the scenes is going to be just as critical for your career as understanding the technology itself.
I want to leave you with one final thought to ponder.
Okay.
If we are successfully fixing these incredibly advanced cutting-edge AI systems by forcing them to adopt century-old human corporate structures like middle management, org charts, and standardized request forms, does that imply that human bureaucracy is actually a universal law of intelligence?
Oh, wow.
Or, as these multi-agent systems scale and become even more capable, will they eventually evolve past our models and teach us a completely new, unimaginable way to organize ourselves?
I guess we'll just have to wait and see what the digital freelancers figure out. Thanks for joining us on this deep dive.